please send an email to oliver.woodruff.bov@gmail.com. I will be pretty responsive. I have the ability to work from home, and I wanted to be able to share this. Oh, by the way, it's Pi Day, so I'm wearing my Pi t-shirt. You're welcome, Fever. All right, so I'm going to change screens.
Okay, so we're starting with question 6. We have the MacLaurin series for a function f is given by the sum n equals 1 to infinity of -3 to the n minus 1 over n times x to the n. We're given the right out of the polynomial as well. And we're told that f of x converges for the absolute value of x less than r, where r is the radius of convergence of the MacLaurin series. So A is use the ratio test to find r. The ratio test is what we need to understand first. The ratio test says the limit as n goes to infinity of a over n plus 1. That definitely wasn't the correct words, but there we go. Come on. Since we are here and I'm struggling with my phone to record, I'm sorry. We have 3 outcomes. We have the limit equals 1, and remember it's the ratio test because we're taking the ratio of the consecutive terms. We have less than 1, and we have greater than 1. If our ratio test tells us that our limit is equal to 1, we know nothing. This is not helpful. This doesn't tell us anything. If it is less than 1, we can say that the terms are getting smaller, so that means we're going to have something that converges. If it is greater than 1, that means the terms are getting bigger, so we have something that diverges. We will need this to figure out what values of x allow this to occur. Because we're looking for the radius of convergence, we're going to be using this here. I'm going to make that nice and bright. All right, so RA is whatever's in that nth term. So RAN is -3 to the n minus 1 over n times x to the n. So we are going to perform our limit n going to infinity of, we want n plus 1, so that's -3 to the n, x to the n plus 1 over n plus 1. Don't forget the absolute values, which I 100% almost always do. This will be crucial because we do have a negative there. Now, because I'm dividing by a to the n and I am using a fraction, I'm just going to multiply by the reciprocal. Mathematically, they mean the same thing. So now I'm just going to flip this term a to the n. So I have n on top now, and then I have -3 to the n minus 1 times x to the n, closing out my absolute values. All right, cool. Now I want to cancel things and group them nicely. I'm going to set this equal. Don't forget to rewrite your limit. It's great practice, even if you think you're going to run out of space. -3 to the n and -3 to the n minus 1. When I cancel those terms, I'm just left with -3 in my numerator. It'll turn into 3 because we're in absolute values, but don't drop that negative. All right, I have x to the n plus 1 and x to the n. That leaves me with x. And we're going to multiply that by n over n plus 1. Cool. We're really close to simplifying this into something. We want to get rid of the n's so we can start thinking about what our x values are going to be. I'm sorry, this keeps going in and out of focus. All right. N over n plus 1. 9 over 10. 10 over 11. 99 over 100. All of those are going really close to 1 as n goes to infinity, so that part goes to 1. Our final limit that we're going to have from the ratio test is, if I can get my pen to work, limit as n goes to infinity of the absolute value of -3 of the x. So I'm going to say 3, the absolute value of x. And since we're looking at that convergence, we want this to be less than 1. So we want to solve for the relationship here. I'm going to go ahead and divide both sides by 3, divide both sides by 3. Absolute value of x. We can get rid of the limit because we're done with n's now. It's less than 1 over 3. Now, the question is asking us to find r. So, the relationship between x and this number, r, is equal to 1/3, because that's our distance. All right. In AP, the scoring that we have to pay attention to is you're going to get 1 point for setting up the ratio. So 1 point for the ratio here or here. 1 point for computing your limit. So that's a point here somewhere. And then you have 1 point for just stating the radius. So do not forget to state the radius. Since they define r as the radius, you don't have to write it out. You just want to make sure that you are as clear as possible. All right, part B. I'm going to put here. I just need to make more space. Did not think this part through. I'm going to put it under my laptop. Cool. Part B. Can you see that written? Sure. Sorry, it's going to be ridiculous. I'm going to go back to the right colors. All right. Write the first 4 non-zero terms of the MacLaurin series for f prime of x, the derivative of f of x. So we're given f of x is equal to x minus 3 over 2x squared plus 3x cubed plus, minus ellipses plus our nth term, n minus 1 over n, x to the n, plus ... If we want f prime, we can take these terms and take the derivative because that's all this is asking for. Super nifty. If you want, you can take the derivative directly in the series and then go from there. It's up to you. All right, so from here, I have 1 minus, bring that 2 down, minus 3 to the x, plus 9x squared. Now, I don't have this 4th term, but I can quickly figure it out by this is n equals 1, n equals 2, n equals 3. So n equals 4, plug that into this term. So I end up with minus 27 for x to the 4. So I'm going to take that derivative. I have minus 27x cubed. Pardon the random stripe, I can't draw. All right, so we get 2 points for this. This right here is my answer. Per College Board, that's 2 points. All right, the second part of this question is express f prime as a rational function for x, or for absolute value of x less than r. So if we wanted to express this infinitely, let's go back to our f expression, n equals 1. It would help if I was reading the problem correctly. Negative 3, n minus 1, x to the n over n. If I wanted f prime of x, I could take the derivative directly in here. That turns into n equals 1, infinity, negative 3 to the n minus 1, x to the n minus 1, and then these n's end up canceling. So I can simplify that to negative 3x n minus 1. Now, to rationalize, we're using that radius, this is our radius now, to create a function. So we have f prime of x is going to converge to 1 a over 1 minus r, which is 1 over 1 minus r. Remember, geometric series, this is where this comes from. This is our r, so I have 1 over 1 minus negative 3x, 1 over 1 plus 3x. And that's a point there. If you forget this, or this was not something that was solidified for you, you're only missing 1 point, so you can still get 8 out of 9 if you get everything else correct. I say focus on the things you know you can get correct, then come back to the things that you struggle with. That way you can guarantee points, the average points you need to get a 5 or 6 points on the problems for each FRQ. So you can risk up to 3 points, essentially. All right, the last part of this is going to be C, which is, right, the first 4 non-zero terms of the MacLaurin series for e to the x. Pardon my struggle. So we know we're going to need e to the x. All right. And then use the MacLaurin's series for e to the x to write the third degree Taylor polynomial for g of x. For g of x, I can't spell, which is e to the x times f of x. We already have the f of x terms given in the problem, and it's about x equals 0, so that just means there's no shift in our radius. Cool. So e to the x, we need to memorize that. It is on that list. It's x to the n over n factorial. E for excited, n is excited. Do what you wish there, where n equals 1. Nope, n equals 0. My apologies, n equals 0. All right. Now, the first few terms of this are going to be 1 plus x squared over 2 plus x cubed over 3 factorial, which is 6, plus da 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 da. Mr. Woodruff, why aren't you going beyond that? Because we're looking for the third degree. We're going to need up to the third degree, but that's pretty much it. We'll use the terms we got. Now, for f of x, we have, I'm just preparing. For f of x, I'm going back to the problem we have at the top. It's x minus 3 halves x squared plus 3x cubed. Cool. I don't actually have to go beyond that because there's my cubic term right there. Great. Now, I'm going to take these and multiply. 1 x squared plus 2. Maybe I'll edit this out. Maybe I won't. Who cares? Not me. X minus 3 halves x squared plus 3x cubed. Sometimes it's hard to read math and write it, so I apologize. If anyone's joined my... Okay, cool. No one has. Great. We're almost there. Now, we have to distribute. I don't think you have to completely simplify. I would imagine that you probably should, because it will make it easier on the grader and it will make them happier. I will show you the tricks that you should remember from algebra. Okay, multiplying out that 1, so I'm just going to rewrite the entirety of f of x. So x minus 3 halves x squared plus 3x cubed. Cool. That's our cubic term there. Now, since I'm going to multiply by x, I'm going to only go up to that x squared term, that second degree term, because then I'll get that cubic term, and I don't need anything else. I don't have to weed anything else out. So that becomes x squared minus 3 halves x cubed. Great. Now I'm going to use this x squared, multiply it just to this term here. So I have plus x cubed over 2. All right, and then it's going to be plus dot 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 dots. Now, while I'm simplifying, I'm going to label my T3. That tells me the degree of the Taylor polynomial at x. That tells me that it's centered at x equals 0. And I'm going to start simplifying. So I have my x's. Cool. I have my x squareds. I'm going to box my x squareds. The box method is my favorite. And then I will squiggle, squiggle, squiggle. Don't forget to keep those signs with their coefficients that follow. So I end up with x, because that is just what we have there, minus great, minus 1/2 x squared. I can't do basic algebra right now, or arithmetic for that matter. Then I have minus 1 total, so it's going to be plus 2x cubed, and that's our polynomial. You're going to have 2 points for this polynomial, so that's going to come from the work done here and the work done here with your final answer. The other point for this question comes from the first 4 non-zero terms, so you need to make sure that you include all 4 terms to get that point. All right. If you have questions, please email me. Thanks, guys. Teens, genderless term. Oh, stop. Stop recording.